welcome to a video on section 8.2 for pre-calculus. We are looking at the conic section of an ellipse. So to begin with, let's take a look at the definition of an ellipse. An ellipse is the set of all points in a plane whose distances from two fixed points called the foci have a constant sum. So let's take a look at what that means. So here's an ellipse. So a foci, or foci is plural of focus, okay? So we have two foci, or focuses. You can see them right here and here. They're 2 points. Okay, and they lie on an axis called the focal axis, which is basically the axis that sort of cuts the ellipse, which is like an oval shape, in half along its long axis. It's sometimes called the major axis. Okay, so when the definition says that it's the set of all points in a plane whose distances from two fixed points have a constant sum. So over here you could see that we've got a random point on the ellipse, and it has a distance from one of the foci of D1, and it has a distance from the other foci of D2. And so when you add those two things up, it becomes constant. Okay. If I were to pick another point right here and find that distance and that distance, these two distances would also add up to the same number, whatever it may be. Okay, so let's look at the equation. Okay, so x minus h squared divided by a squared plus y minus k squared divided by b squared is equal to 1. So just to let you know, I do this a little bit differently than your textbook does. Okay, I think that they change the a and the b around a little bit, and I try to keep them in the same spot. And I have a reason for that. It just makes more sense to me. Okay, so let's talk about what all these things are. Well, h and k. So we got h and k is, of course, an important point. And it's not a vertex like the parabola, it's a center. So it's this point right here in the center, right there. Okay. Then we have this a and the b. So a is being squared, and it's in the denominator of the x minus h squared. So I want you to think of a goes with x, okay? So a, which this will always be positive, is going to be the distance, well, it's under the x, so it's going to be the distance left and right from the center of the ellipse to the ellipse. And what I mean, so at the end of this is going to be the vertices. So there's two vertices. You can see those points right there. They're actually on the ellipse. Okay, b is a number that's underneath, or b squared is a number underneath y minus k squared. And think b is under the y. Y, like the y-axis, is going to move up and down. So it's the distance up and down from the center to the ellipse. So that would be, so this is like a. Okay, and then b, this would be b, and this would be b. And so you get these other 2 points. Sometimes they don't even have a name. Sometimes they're called a covertex or covertices. So you could say that it goes to the covertices. Okay, and then the other thing that we have here is c. So c is the distance from the center to the focus on each end. Okay, so from here to here, let me zoom in on that. This is C. So C is a number that's less than the A. Alright, so it's the distance along the focal axis, also known as the major axis, to the foci. Okay, so now we're going to fill out a table here that kind of describes what's the difference if A is greater than B or B is greater than A, and that's going to change some things, and we're going to do an example. Okay? Alright, so first we're going to start if A is greater than B. Okay, A is the number that is underneath the x-axis, and so I showed you that A gave you these distances to the vertices. Okay, if A is greater than B, then that means your focal axis is going to be horizontal, right? So it's horizontal. Specifically, the equation is y equals k, whatever k is. I forgot to highlight B here. Okay. All right. So basically, it's wider than it is taller. It looks like the pictures that you see right here. Okay, so we have an equation to find C. You'll notice that C is not anywhere in the formula. So to find C, we do C squared equals A squared minus B squared. Whoa. Minus B squared. Okay, it's kind of like the Pythagorean theorem in a way, except we're subtracting. Okay. The foci then are going to be at some point H plus or minus this C, comma, K. The vertices are going to be whatever the H is. Remember, H and K is the center. So we're adding or subtracting something from the center to get new points. So the vertices are going to be H plus or minus A, comma, K. So just kind of imagine that. If the center is HK, and I take H and I add A, I'm going to be over here. If I take H and I subtract A, I'm going to get over here. But it stays at the same level along the, it's not moving up or down. That's why the K doesn't change. Okay. The semi-major axis, so semi means half. Okay. So the semi-major axis, which is basically half of the long axis, since A is the bigger one, then it's just A. The length of it is A. The semi-minor axis, okay, the minor axis is the one that's the short one. This is the minor axis right here. So the semi-minor axis would be B. It's pretty much just like the length of half of it. The length of the whole thing would be 2B. Okay, so eccentricity is a ratio of, we use a letter E, it's not the number E, it's the ratio of C to A. Okay, remember that C, I'm going to clear some of this stuff out because it's just getting a little crazy in this picture. Okay, C is the distance right here. A is this distance right here. And so we're looking at that ratio. The closer they are together, the higher the or the closer they are together or further apart they are. Gives you a different variable for eccentricity. So eccentricity is defined, I don't have anywhere for you guys to write this down, but eccentricity basically comes from the adjective eccentric. Okay, you can read about this in your book, and it means off center. So it's basically how off center the foci are. So if you were to, let's open up a new window and I'll show you the GeoGebra thing so you can kind of get an idea of what's happening. Okay, so in order to have an ellipse, you need 2 points as your foci. Okay, so I'm going to go to the conics where you have an ellipse, select 2 foci, and then you have to pick a point where you want it to be. So then you can kind of see that if I have the foci very close together, it becomes almost circular-like. In fact, if you put them on top of each other, you get a circle, like an exact circle. A circle is actually a type of ellipse. But if you spread them really far out, you could see that wherever the center is to the A value and the C value are almost identical. Okay, so that's sort of the variation of the eccentricity. Okay, so let's do an example. So in this part right here, let's do x squared over 25 plus y squared over 9 is equal to 1. So to begin with here, I'm just going to keep it centered at the origin so that you can see the rest of it, and then we'll throw h and k into the mix. Okay? Alright. So the first thing I'm going to do is find a and b. So 25, that is a squared. So if a squared is equal to 25, we know that a is equal to 5. We just take the square root. Okay? So our center is at the origin, and that 5 tells us to go left and right 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, this is the A on each side. Now we're going to use B. So B squared is 9 from here, which tells me that B is 3. So since B is underneath the y-axis, I'm going to go up and down 3. 1, 2, 3. 1, 2, 3. Always counting from the center. So there's our B's equal to 3. B is equal to 3. And from here you can draw the ellipse. Kind of connect those 4 points into the sad football shape. I can never draw this very well. It's even harder on a computer. Don't worry about it making it perfect, okay? So that's what it looks like, but we still have to find the foci. So to find the foci, what we need to do is do c squared equals a squared minus b squared. This is the equation you use if a is greater than b. Okay, since a is 5 is greater than 3, this is the case that we're doing. So let's see, a squared minus b squared would be 25 minus 9, which is 16. And of course we have to square root it. So c is 4. So we're going to count along the major axis here, by the way, if you can't tell, the major axis is the long one. This is the major axis. And so my foci are going to be on that. And I'm going to count 1, 2, 3, 4. 1, 2, 3, 4. There are your foci. We'll call it F1 and F2. Okay, so now let's flip it around, and we're going to make b greater than a. You're going to see a lot of similarities, and you're going to see some changes here. So this time, if b is greater than a, b is the up or down number, it's going to be longer, you're going to have a vertical major axis, and the equation will be x is equal to h this time. Okay, and so this time b is greater than a. Okay, to find the foci, you're going to do c squared is equal to b squared minus a squared. It's the same formula, we're just swapping them. Basically, we always want the bigger one first. You'll know you did it wrong if you're square rooting it and you're getting a negative and you're getting an imaginary number. That's how you know you swap them. Okay. The foci this time are going to be moving along the up or down, and so we're going to add it to k. So it's going to be h, comma, k plus or minus the c. The vertices are going to be h, comma, k plus or minus b this time, because the b is the up or down number. And the semi-major axis is now up or down, so this is the b, and then the minor one would be left and right, which is a. The eccentricity is going to be c divided by b this time, because that's the major axis is b. Okay, so let's look at an example. Let's do x squared over 4 plus y squared over 16 is equal to 1. Okay, so no h or k, so the center is at 0, 0, just like with parabolas. So I'm going to put a dot at 0, 0. That's my center. And let's find a and b. So a is the square root of 4, so 2. So I'm going to go left to right 2. Okay, b is the square root of 16, which is 4. So I'm going to go up or down 4. Okay, and I'm going to draw my attempt at an ellipse. Now that one looks pretty good, actually. Okay, so that's what it looks like. Let's find our foci. So we're going to do c squared equals, and this time I'm not going to do 4 minus 16, I'm going to do 16 minus 4, which is 12. So we're going to take the square root of 12, and it's about 3.5-ish. Okay, so I'm going to go up and down, because this time my major axis is, or my focal axis is this one. It's the big one. It's wherever the big one is. So I'm going to go up and down 3.5 about. Just eyeball it. Okay. There she is. So you can see the difference. Everything's just kind of turned on its side. Alright, so let's do a couple more examples. First we're going to do some with h and k. Okay, so let's start by finding our center. So h, remember, is with the x and the y's with the k. You'll notice there's subtraction signs for both. So my h is going to be -3. My k is going to be +1. So I'm going to put -3, 1 as my center. The rest of this is pretty much the same. It's just centered at a different location. So a comes from the 49. So a is the square root of 49, or 7. So I'm going to, remember, it's under the x. X goes left and right, so I'm going to go left and right from here. So 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, and my b is the square root of 25, which is 5. So up or down 5. 5. 1, 2, 3, 4, 5. Okay. Make your beautiful oval. Okay. The foci. C. C squared is equal to, the big one is 49 minus 25. Okay, so c squared, ooh, that was fun. C squared equals 24 square root h. That's about not quite 5. It's very, very close to 5. It's about 4.9. Okay, so let's see. 1, 2, 3, 4, 5, practically 5. 1, 2, 3, 4, practically 5. Okay. Now in Math Excel in your homework, you're going to have to give the exact coordinates of these points. And so that's where you're going to want to use these formulas like these. Especially if your A and your B or your C are not nice numbers. Like I could see exactly where this vertex is right here. That's the point 1, 2, 3, 4, 1, right? But where exactly is this green one? Okay, well, this is, you're going to have to simplify these. It's 4 times 6, so it's 2 root 6. And so this one is A is greater than B, so I'm going to take H and add and subtract that C. So this is H, which is negative 3, plus 2 square root of 6, comma 1. This one is negative 3 minus 2 square root of 6, comma 1. All right, you have to give the exact coordinates at certain points. Okay, let's take a look at example 2. Example 2 is not in the correct form, you may notice. Like, where's the a squared and the b squared? Where's the 1, right? You have to have that 1 in the formula. So in this case, we are going to have to fix this. So that when you don't see the 1, because this is supposed to be a 1, we're going to make it a 1. We're not going to subtract, we're going to divide. So I'm going to divide everything by 100. Okay? When you do that, some things start to come into play. So this is a 1. 4 goes into 125. Oh, look, there's the b squared. There she is. 25 goes into 100 4 times. Oh, there it all is. Oops, and I forgot my plus sign. Okay. So let's find the center, let's find A, let's find B, let's find C, all that. So my center, HK, is 3, 0. So it's over here. A is the square root of 4, which is 2. So I'm going to go left and right 2. B is the square root of 25, which is 5. So I'm going to go up or down 5. 2, 3, 4, 5. All right, there she is. So this is one where B is greater than A, so our axis is going up and down, our major axis or focal axis. Okay, let's find C. So C squared is the big one, 25, minus the little one, 4. So C is the square root of 21, which is about 4.6. So we're going to make sure you go on the right axis, right? This is the axis that we need to use because that's the big one. Well, here, this was the major axis. All right, so we're going to go up 1, 2, 3, 4.6, down 4.6. Okay. Or if you need the exact coordinates of those foci, you would do, since b is greater than a, we would use this formula. You would add and subtract c from the k, not the h this time. So this is going to be over 3, comma, and then k was actually 0. So I'm just going to make it plus the square root of 21. And this one's going to be 3, comma, minus the square root of 21. 21 is not simplifiable. Okay, so that's graphing them. Let's work on finding some equations. So find the equation of ellipse with the given conditions. The endpoints of the axes are plus and minus 4, comma 0 and plus or minus, or 0, comma plus or minus 5. So the first thing you're going to want to do is sketch this. So 1, 2, 3, 4, 1, 2, 3, 4, 5. So this is a pretty simple case. It's almost circular because I didn't do a very good graph, but we can see this is A is 4, and B is 5. We can also see it's centered at the origin. So this is going to be x squared, we don't have an h, over 16, don't forget to square it, plus y squared over 25 equals 1. Everybody forgets the equals 1. Don't forget the equals 1. Okay, B. The foci are at plus or minus 2, comma 0 and the major axis length is 10. Okay. The foci are at plus or minus 2, comma 0. So let's see. 1, 2. So these are foci. Comma foci. The major axis length is 10. The major axis is this thing. It has to be going this way because the foci are on it. So the endpoints of this are 5 and 5 because the whole thing is 10. So it looks like in the middle here we've got the center as the origin again. We've got A is 5. So we got x squared over a squared is 25 plus y squared over, I don't know what b squared is, equals 1. So I don't know how tall it is. Okay, that is the worst ellipse in the world. But I don't know what b is. But I do know what f is. F is 2. Or not f, sorry, c. I was looking at the f. So C is 2. I know A is 5. I can work backwards to find B. Excuse me. So let's use that formula. C squared equals A squared minus B squared. I know that A is the bigger one, so it's 25 minus B squared. And C is 2. So 4 equals 25, that's in the way, minus b squared. Let me write it over here. So that tells me that b squared is 21. And that's all I really need to know. I don't need to square root it because b squared goes here, so just put the 21 there and you're done. All right, that is it.